discuss first two things. One is redistribution of charges and loss of energy. So first of all, we'll discuss redistribution of charges. What does it mean by redistribution? Redistribution of charges, when the charges they start sharing one another, and then again the redistribution takes place. So what exactly is this? Redistribution of charges, what we do that we take two insulated conductors. So say these are the two insulated conductors we have taken. One is this and another is this. These are the two insulated conductors taken. And it has a positive charge on this, some positive charge on this, and it has also some positive charge on this. Okay, so these are the two conductors. One capacitance C1, say C2, charges are Q1 and charges are Q2. So, and these are A and B. These are the two conductors which we have taken. And you know, this is that the charge is what all of you know, C1 V1, and Q2 will be what? C2 V2. C1 C2 are what? The capacitances. C1 C2 are the capacitances, Q1 Q2 are the charges. Now if two conductors are joined, now they are joined by what? A thin conducting wire. We have joined them by thin conducting wire. So what happens? If we join it by thin conducting wire like this, do you know the charge will flow? Charge will flow from higher potential to lower potential. We know that the charge always flow from higher to lower potential. So charge will flow from higher potential to lower potential. Remember this thing. It's very important that charge flows from higher potential to lower potential until their potential becomes equal. Now charges are redistributed. So charges are redistributed. It goes on till their potential becomes what? Equal. So charges are distributed. Now if I ask you what is total charge? So total charge is actually what? Q1 plus Q2. Okay. And that combined capacitance, if I ask you what is combined capacitance, both of, you know, that combined capacitance will be C1 plus C2. So when the common potential will come, you know that when you connect them, there will be a common potential. So common potential is always a total charge upon total capacitance. So this will be the common potential. When the shearing will take place, there will be a common potential. What is the total charge? Q1 plus Q2. What is the capacitance? C1 plus C2. Can I write in place of Q1 C1 V1 in place of Q2? Yes, C2 V2 upon C1 plus C2. So this is the expression for the common potential. Remember C1 V1 plus C2 V2 upon C1 plus C2. This will be the common potential once the common potential is attained by flowing of the charges from higher to lower potential. And then if after redistribution, if after redistribution, do you know what happens? If after redistribution of charges, say Q1 dash and Q2 dash are the charges, say these are the charges. So very simple. You know that Q1 dash can be written as C1V. Why V? V is the common potential. Q2 dash can also be written as C2V. V is the common potential. So we can get the ratio Q1 dash by Q2 dash is equal to what? C1 by C2. So this is very important if the charges are Q1. So we can say that the charges are the ratio of the capacitances. They are the ratio of their capacitances. So this is the sharing of charges, redistribution of charges. when you connect them, you get a common potential and their charges are in the ratio of their capacitances. So redistribution of charges is this, when you connect two insulating conductors by a wire. Now, when there is a redistribution, do you know there can be a case where loss of energy can take place. So there is a loss of energy in redistribution of charges. In redistribution of charges, when you connect them, there will be some loss of energy. Are you getting it? So we can calculate the loss of energy of redistribution of charges. What is the initial energy? Initial energy total will be what? Half C1 V1 square plus what? Half C2 V2 square. This was the initial energy. Why? Because C1 and C2 were what? The capacitances, you remember? And V1 and V2 were what? Potential. V1 and V2 were potential. So this is initial energy. Total energy. Total initial energy. Now, when connected, जब कनेक्ट कर दिया था, when connected, a common potential was there. A common potential exists. What was that? It was V equal to C1 V1 plus C2 V2 upon what? C1 plus C2. So what will be the now the final energy? So U final will be, do you know what? Half C1 V square plus half C2 V square. So can I write it like half C1 plus C2 what? V square. So this is half C1 plus C2, and in place of V I can write C1 V1 plus C2 V2 upon C1 plus C2 what? Whole square. So this is the final energy. This is the total final energy. Are you getting it? How you got it? This was the final energy. And then loss. Loss in energy is very simple. It will be U initial minus U final. So initial is half C1 V1 square plus half C2 V2 square minus half, and it will be C1 plus C2. It can cut down, so you can write C1 V1 plus C2 V2 whole square by what? C1 plus C2. This is the energy loss, and further we can elaborate it. If I take the part, how I am getting half, you know that 2 C1 plus C2 common in this, then by taking 1 by 2 C1 plus C2 common, we'll calculate it. It comes like C1 square V1 square plus C1 C2 V1 square plus C1 C2 V2 square plus C2 V2 square minus C1 V1 square minus C2 square V2 square minus 2 C1 C2 V1 V2. So it is a elaborated form, and you take what this common, and after that this will be 1 upon 2 C1 plus C2, and from this C1 C2 can be common, and in bracket it will be V1 square, very simple, plus V2 square minus 2 V1 V2. So the calculation will be at the last very simple. This will be C1 plus C2, C1 C2, and it is V1 minus V2 what? Whole square. So this is energy loss. C1 C2 upon 2 C1 plus C2, and in bracket it is V1 minus V2 whole square. So this will be the energy loss. So what we discussed was the redistribution of charges, how the two conductors were connected, and then the redistribution of charge took place, the charge is transferred, then we got the common potential, and then we can even get their charges ratio. If there is a common potential, there will be a loss of energy. Loss of energy is what? This is very simple. Initial minus what? Final. Initial is this, final will be this, common potential. Then you solve it out. Though this is very simple, but calculation is there. You will take C1 plus C2 common in this, and then in bracket this complete form will come where V1 minus V2 is the whole square. So V1 is the potential of first capacitor, V2 is the final, C1, C2 are their capacitances. So we'll have the numericals based on this. So this is related with the charges. Now one important thing is that we are going to solve out some numericals based on series and parallel also. But before that, just I will explain you Wheatstone Bridge in capacitor. So some of you may be knowing Wheatstone Bridge principle. It will come in resistances, but it is also applicable in capacitors. It's a system, you know that there is an arrangement of the capacitors like this. If there is an arrangement of the capacitors like this, see, this is a type of a bridge, and this is the A and B. Say this is P, this is Q, this is R, this is S, and G. These are the name of the capacitors. So if the arrangement is like this, and what is the condition, though we are going to derive it in current electricity, condition is that if P by Q is R by S, if P by Q is R by S, or P by R is Q by S, do you know what happens? In this we neglect G. G capacitance is neglected. Why? Because at these ends, say this is C, this is D, the potential becomes what? Same. VC is equal to VC. So no charge is going to transfer. There will be the G will be what? It will be neglected. It will be removed. This is Wheatstone Bridge principle. So simply then we are going to calculate P and Q will be in series, and then R and S will be in series, and then we will solve it out. This is Wheatstone Bridge principle. Remember, this AND should be vertically cross these two junctions. Remember, if it is in horizontal, then it will not be applicable. It has to cross these two ANDs in vertical. So if P by Q equal to R by S, we neglect G. Why? Because the potential at C and D becomes what? Same. This we are going to prove in current electricity, but we are going to apply in numericals in what? Capacitors. So now I have some numericals. I'm going to discuss one by one. Though already we have discussed series and parallel, and there are some figures which we can see here, and we have to calculate what net capacitance in the given figure. The first one, if you see the first figure, you have to find out net capacitance given in the figure. This is CAB. So you have to find out across A and B. And you know, each is given of 1 microfarad. So consider it as C1, C2, C3, C4, and C5, name them. Now always remember, when we solve it, it is in series and parallel mixed. But always we go through the closed circuits. Never go through the open. So closed circuits. So first we will solve it, and then we will come to out to the AND point. So here if you go inside this circuit, this C1 and C2 are in what? Series. So C1 and C2 are in series. Do you know what will happen? 1 upon C1, 2 will be 1 upon C1 plus 1 upon C2. You know the series 1 by 1 plus 1 by 1. It will be 2. So C1, 2 will be 1 by 2, what? Microfarad. Then they both are in series, but they are parallel with C3. You see the two ends are there, so they are parallel. So parallel with what? To C3. So can I write C1, 2, 3, C1, 2 plus C3. So in parallel we write like this. So half plus what is C3? It will be 1. So it is 3 by 2 microfarad. Now, do you know these two are in series, then parallel to this, then all three are in series from this AND to this AND. So net capacitance will be 1 by C, 1 by C4 plus 1 by C1, 2, 3 plus 1 by C5. So can I write 1 plus 2 by 3 plus 1? So it will be what? If you say solve it, 3, 1, 2, 2 plus 2 by 3, it is 8 by 3. So solving it out, it becomes what? Reciprocal 3 by 8 microfarad. So again repeating, 1 and 1 will become what? 2. So it will be a reciprocal half, half and 1 will become 3 by 2, then 2 by 3 plus 1, then it is 8 by 3, reciprocal is. So what is CAB is 3 by 8. Now come to this one. This one is very simple. How we are going to calculate? Do you know? All three, this one, 2 microfarad, 3 microfarad, 5 and then 10. These are the two junctions. If you see here, what two across this, two across. So these three are in parallel. So very interesting how you write it. It is like this. You write it this. So all three are in parallel and this is in series. So this is 2, this is 3, this is 5. I have changed the arrangement like this. Why? Because there are two junctions and the charge are not same. Charge get distributed in parallel. So all three, 2 plus 3 plus 5. So it will be 10 microfarad. Okay, this and this is again 10. So this is 10. Say this is C dash of these here and this is C1. So what will be net C? 1 upon 10 plus 1 upon 10. It will be 2 by 10 and you reciprocate, it will be 5 microfarad. So in this case you get 5 micro. Again repeating, all three are in parallel. 2 plus 3 plus 5, it will be 10 and then this 10 in series and this reciprocal is this. Now come to this point. This one, if you see this one is what? 2 by 2 equal to 2 by 2. 2 by 2. This is Wheatstone Bridge. P by Q equal to R. So we are going to neglect 5. So if you neglect 5, what will happen? Do you know this circuit will be like this? You see it. We are not going to take what? 5. So A and B, this will be like this. 2 microfarad, 2 microfarad, 2 microfarad and 2 microfarad. So can you solve it? Yes. Very simple. How we are going to solve it? These two are in series. These two are in series and then they are in parallel. So 2 and 2 in series will make them what? 1 microfarad. 2 and 2 in series will make them 1 microfarad and then they are in parallel. So ultimately it will be 2 microfarad. So again repeating, 2 and 2, it becomes what? 1. 1 by 2 plus 1 by 2 is 1. 1 by 2 plus 1 by 2 is 1 and then they are in parallel. So it is 2 microfarad capacitance here. So this is how we are going to calculate. Now there are three questions. Find the capacitance of arrangement of 4 plates of area A and distance D in here. Two figures are given. One is A and then another is B given here. So we have to calculate it and then there is another question. Find the capacitance between A and B. So how we calculate the capacitance in this case? If you see there are 4 plates. One is at the positive and the other is negative. So it will get positive, then it will get negative, then it will get positive, then it get negative. If you see plate area is A, distance is D, there are 3 capacitance. C1, C2 and C3 and very interesting, they are in what? They are in parallel. So why they are in parallel? Positive, negative, then positive, negative, then positive, negative, C1 plus C2 plus C3. So for this it will be epsilon naught A by D. Remember epsilon naught A by D? Epsilon naught A by D was in air medium, epsilon naught A by D. So the answer for this will be 3 epsilon naught A by D. So this will be the answer for this one because there are 3 capacitors acting like capacitors. So in this one, if you see this is positive, so it will get positive, this will be negative, then this will be negative, then this will again be positive. But this time you see that there is no capacitance in between, there is no capacitor here. So we have only one capacitor here, C1, and the other one is here. And again they are in parallel. So C1 plus what? C2. And then simply it will be epsilon naught A by D plus epsilon naught A by D. So for this, the capacitance will be 2 epsilon naught A by D. So this is an arrangement of the plates. Now, this is another question. You have to calculate, find capacitance across AB. Now, if you see this circuit, we have 360 microfarads capacitor, 210, and the outer one is 40. So what I have told you, that always solve the closed path. Now, if you see these two are in what? They are in parallel. So when they are in parallel, 10 plus 10 for this, say this is C1, C2. So you will get C1 to 20 microfarad. Got it? They are in parallel. Now all these 3 are in what? Series. So if I ask you, this is say C4, C5, C6. For these three, 1 by C dash will be 1 by C4 plus 1 by C5 plus 1 by C6. So if I add them, 1 by 60 plus 1 by 60 plus 1 by 60, it will be 3 by 60. So what again reciprocated, you will get what? 20 microfarad for this. Okay, so 20 is for this, for entire it is 20. And do you know now they are in what? Parallel. Why? Because across the junction they will be in parallel. So finally, if I ask you from these two, what you are going to get is say C double dash, it will be C12 plus C dash, it is 20 plus 20, 40 microfarad. Okay, and then last one is this is in series with them. So at the last, 1 by C will we say it is C7, so 1 by C will be 1 by what? C double dash plus 1 by C7, so 1 by 40 plus 1 by 40. Again you solve it, it becomes 2 by 40 and reciprocate it, the answer will be what? 20 microfarad. So this is the capacitance between A and B. Again repeating, solve these two, they are in parallel 20, these three are series, so it will be 3 by 60, 20. Then they are in parallel, though it will be 40, and then with this series it will be 20. So these are the questions related with the series and parallel, how to solve them. So go through them, and thank you. Regularly watch my videos.